Hello, welcome back everybody. Mr. Renneker here again, and today we are going to start to talk about how we can find the volume of pyramids. So of course that main objective for us by the time we're done with the lesson is going to be to evaluate the volume of any pyramid using a formula that we will discuss here in just a few moments. Now we already know a little bit about finding the volume of prisms from some of our more recent lessons. We're going to borrow some of those ideas and use them to help us with the volume of a pyramid here. Let's go ahead and get started. So our key idea starts like this. Now, normally I like to do an in-person demonstration, which unfortunately I won't be able to do, of course, via this video. But the demonstration helps us identify what we see over here in this image and, of course, in the description, which says the volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. Now, there are some things there that we should find familiar. For example, the area of the base was an idea that we used all the time when finding the volume of a prism. And then the height, we would call the height of the prism before, now it's just the height of the pyramid. But notice here in our formula, we're still taking capital B times H, or the area of the base times the height of the three-dimensional figure. So that part of the formula is going to be exactly the same. The new part here is that actually we're going to take that product, we're going to multiply those two, and we're going to take 1/3 of it. So notice that they did multiply this by 1/3. Sometimes in some other applications, you'll see the same formula as area of the base. It's not a very good B. Area of the base times the height of the pyramid divided by 3. And in different applications or different problems, either version could be helpful here. We're going to use that and jump into our first example, which simply asks us to find the volume of the pyramid that you guys see here. So we always start by writing out our formula so that we understand all the pieces that we need to find or substitute in. So we have 1/3 times the area of the base. Please remember that's what capital B stands for, and then the height of the three-dimensional figure. Now, when you guys look at our image here, notice that the height is kind of this superimposed or make-believe line. Here it's red, it's drawn inside of our pyramid. The reason is because right down here in the corner, you'll see what appears to be a right angle symbol, and that's there because the base of the pyramid and the height, they have to be perpendicular. They have to meet at 90 degrees. So that's why you see that extra line drawn in there. Past that, this is one of the straightforward examples where we actually already have all the information we need. We needed the area of the base, capital B, and notice right here they gave us capital B and just told us that number is 48 square millimeters. I don't have to calculate it. I don't have to otherwise find it. It was just given to me. So I'm going to take 1/3 times 48. And the last thing I need is the height of the pyramid. And again, we already pointed that out here with the yellow arrow. It is 9 millimeters. So we'll take 1/3 times 48 times 9. Past this, it should just be some calculations either by writing things out or, of course, using a calculator. And however you do that, you should find that the total volume of the pyramid ended up to be, 144, and that should be cubic millimeters or millimeters cubed. So you are going to see a couple problems like this where all the information is provided to you, but that's not always going to be the case. You might be curious, why did they just go ahead and give us the area of the base? And I'll take just a brief moment to point that out. If you look at this pyramid and looking at the shape of the base, it has 1, 2, 3, 4, 5, 6 sides. It's actually a hexagon for a base, or what we call a hexagonal pyramid. And many of us don't have the skill set required to actually find an area like that on their own. So if you run across any pyramids that have a base that is a pentagon, a hexagon, an octagon, or any other polygon that has more sides than what we're comfortable dealing with, it's likely that they're going to give you this scenario where they just provide the area. In our next example, we're going to have to go ahead and find the area of the base, or capital B. So here in example 2, still finding the volume of a pyramid, we see in part A that this time our base is actually a rectangle. I know that because the side lengths are 3 and 4 feet. They're not identical, so it's not a square pyramid here. But keeping that in mind, I'm still going to use the same formula for volume, which is 1/3 times the area of the base, or capital B, times the height of the pyramid. But this time, to find the area of this base right down here, to find all that space, I'm actually going to have to calculate it. And to find the area of a rectangle, well, we know we just take its base times its height, or in other words, we multiply the dimensions together. So that's why we have the dimensions of these side lengths here, so that I can simply take 3 feet times 4 feet. Oh, I wrote 14, my apologies. 3 feet times 4 feet, which is, of course, just 12 square feet. So now we have the area of the base. So now I'm ready to substitute that into my formula. So it is 1/3 times 12 times, of course, the height of the prism, which they did mark for us right over here. And they usually will. And that would be 7 feet. Just like our last ones, we'll go ahead and calculate that out here. And you should end up with a total volume here of 28. And again, this time it's going to be cubic feet. So again, the main purpose of these problems is to make sure you see examples of times when you are going to have to actually find the area of the base versus being given that information. Let's take a look at part B. And part B is a really, really interesting looking pyramid here. The first thing I'm going to focus on is the base. I can kind of outline that here. And I see that the base is actually its own triangle, making this a triangular pyramid. But the picture can sometimes be confusing because we have one height here, it's marked, as 10 meters, and we have one height down here for something different marked 6 meters. There's a lot of extra lines and measurements that can sometimes be a little out of hand if we're not careful. But to help us stay on track, I'll start with the formula for the volume of a pyramid, which is 1/3 times the area of the base times the height of the pyramid. But again, to find this area here at the bottom, I'm going to have to actually calculate that on my own. They didn't provide that for us. So I have to remember, how do I actually find the area of a triangle? To find the area of a triangle, which the base is, I have to take 1/2 of the base of that triangle times the height of that triangle. I'm going to erase some things to help us see a little bit more clearly, but that's why we have so many extra lines here, is because we need so much extra information, or at least it feels that way. So we're going to take 1/2 times the base of that triangle, which appears to be this edge right here. And I know that that edge is the base because it's connected here to this height that we see, which is a little bit extra. And that base, let's see, was 17.5. And then the height of that triangle, again, remember, base and height of things, whether it's a triangle or a prism or a pyramid, they're always going to be perpendicular, which is why they have that right angle symbol. So the height here is going to be 6 meters. And one more time, to just give yourself a few moments to actually do those calculations. And you'd get an area of 52.5 square meters. So we finally have the area of the base. We can go ahead and plug that in the rest of our formula over here. So we have 1/3 times 52.5 times the height of the actual pyramid, and that's what our last little 10 meters is for there. So again, the main point here is just realizing that sometimes you have to calculate that area before you can find the total volume, so be ready to do that. But to finish this problem out, we'll go ahead and take 1/3 times 52.5 times 10, and you should actually end up with a total volume of 175 cubic meters. So those are the two primary things that you're going to do here, but we are going to wrap up with a couple problems you can try on your own if you'd like to check your understanding before getting to the assignment. So let's take a look at those as our last step. So here we have three pyramids that you can try on your own. Some of them, they do provide you with the area of the base. Other ones, like 2 and 3, they do not. So you're going to have to try that part on your own. But go ahead and pause the video now if you'd like to try that. And then, of course, in a few moments, we'll take a look at the solutions together. So here we are with our solutions. Number 1 was 42 cubic feet. Number 2 was some not as clean or not as friendly numbers, but a volume of 186 and 2/3 cubic inches. And finally, number 3 was 231 cubic centimeters. And there we have it. That's primarily what you're going to do with volume of some prisms here. Of course, if you have any questions, feel free to reach out to me via email. Otherwise, good luck on the assignment, guys, and I will see you next time.